PT6A-60 series engines may be operated to a scheduled hot section inspection interval, or alternatively, the hot section inspection frequency may be based on engine condition trend monitoring in accordance with the relevant aircraft gas turbine operation information letter. If trend monitoring is introduced partway through engine life, a compressor wash and hot section inspection must be accomplished to establish a performance baseline. A performance check is recommended prior to and following any hot section inspection to assess performance improvement. Actual performance parameters plotted against targets on a worksheet will provide a useful permanent record. Please note that due to the time restrictions of this program, some sequences have been shortened. Although a PT6 hot section inspection may be conveniently performed on the wing and scheduled during low utilization periods, this program will show the hot section inspection being performed in an engine shop environment. Please note that for this program, a PT6A-65 engine will serve as a typical example of the PT6A-60 series. Before proceeding with the actual hot section inspection, we will inspect the engine oil filter and the engine chip detector. Remove the self-locking nuts and the plain washers securing the oil filter cover to the compressor inlet case. Remove the cover from the inlet case together with the preformed packing and the Teflon spacer. Remove the filter element from the filter housing using the oil filter element puller. Insert the collet teeth into the center core of the element and expand the collet by unscrewing the small knurled rod. Then withdraw the element by turning the large knurled nut clockwise. Check the filter element for metal contamination. When visible metallic contaminant is present on the filter, proceed as outlined in the Pratt and Whitney Canada Maintenance Manual. Place a suitable container under the reduction gearbox and remove the chip detector from the boss at the 6 o'clock position on the front case of the reduction gearbox. If there are some magnetic particles on the poles of the chip detector, refer to the maintenance manual for proper action to be taken. To gain access to the hot section of the engine, we must split the engine at C flange and remove the power section from the gas generator section. Remove all except 4 bolts on flange C. Mount the power section sling on the propeller shaft mounting flange and secure it with 4 bolts. Disconnect the clevis end of the push-pull cable from the propeller reversing lever. Note the presence of a spacer in the propeller reversing lever. Remove the propeller governor interconnecting rod from the air bleed link on the propeller governor. Remove the nuts and bolts securing the push-pull cable lock plate to the front lifting bracket. Slacken the nut, securing the push-pull cable to the front lifting bracket. And swing the cable clear from the lifting bracket. Disconnect the T5 trim leads and the T5 harness leads from the terminal on the gas generator case. Disconnect the PY pneumatic line at the center fire seal. After attaching the hoist to the power section sling, remove the remaining bolts and nuts at flange C. Carefully separate the power section from the gas generator case and install the power section in the power section stand. A word of caution at this point. The interstage sealing rings are the mechanical separation between the combustion section and the inter-turbine area. To ensure that the sealing rings are reinstalled in the same relative position, mark them using an approved marker. Leakage at the interstage sealing rings will result in the loss of cooling air, P3. Compressor turbine tip clearance is one of the most important operating clearances in the entire engine, and small variations have a direct effect on engine performance. In checking the tip clearance, always use a narrow feeler gauge or wire gauge. Measure the tip clearance at the end and the middle of each segment. Without rotating the compressor turbine, record the 30 measurements on a worksheet and determine the average tip clearance. At constant power, the symptoms of too much tip clearance are high T5, high fuel flow, and low NG. If the tip clearance is unsatisfactory, replacement of the compressor turbine shroud segments may be necessary. The next step in the hot section inspection is to remove the combustion chamber inner liner in order to gain access to the vane ring assembly. Remove the 14 bolts securing the inner liner to the outer liner flange. Do not attempt to pry the liner loose with sharp-edged or pointed tools. Install the puller and remove the inner liner. Make sure that you pull evenly. The next step is to remove the compressor turbine disc assembly. Install the compressor turbine disc wrench on C flange of the gas generator case. Ensure that the slots on the wrench are correctly seated on the balancing rim of the turbine assembly. Install the nylon protective sleeve before uncrimping the turbine bolt cup washer. Screw the inner part of the spreader into the compressor turbine bolt. Make sure that the crimps on the cup washer are lined up with the slots on the spreader. Turn the hexagon nut until the spreader is located inside the cup washer. Then turn the outer part of the spreader to unlock the turbine bolt. Remove the spreader. Using a conventional socket wrench, break the torque on the center bolt. Remove the bolt, the key washer, and the nylon protective sleeve from the center bore of the turbine disc. To remove the turbine, we must use a puller. We will demonstrate on a practice turbine how to use the tool, then we will do it on the engine. Insert the compressor turbine disc puller, making sure that the puller lugs go behind the disc. Rotate the inner part of the tool until the lugs on the puller are between the slots on the turbine disc. Now, rotate the outer part of the tool until the outer lugs fit in the disc slots. This will position the puller properly. Release the disc snap diameter by turning the hexagon knob on the end of the puller. It is most important to ensure that the compressor turbine blades are not contacting the shroud segments when withdrawing the turbine disc assembly. Each time the hexagon knob is turned, move the turbine to see that it is not binding. Remove the turbine from the gas generator. The puller can be used as a handle. Remove the puller and install the assembly in a suitable container on a clean bench. If the engine performance is good, it is not necessary to disassemble the engine further. But if the vane ring or the shroud segments need to be replaced, proceed as follows. It is suggested, before removing any parts from the gas generator case, that their relative positions are marked for ease of assembly later using an approved marker. Remove the 8 bolts and tab washers securing the baffle plate to the flange of the number 2 bearing cover, and remove the bearing cover baffle. Using a puller, remove the number 2 bearing cover. Remove the 16 bolts and tab washers securing the lock plate to the gas generator case. Withdraw the lock plate, the vane ring, the small exit duct, and the shroud housing assemblies. Mark and remove the number 2 bearing cover flange using jacking screws. To gain access to the diffuser section, it is necessary to remove the combustion chamber outer liner. Disconnect the leads from the spark igniters and remove the 2 igniters. Number the position of each nozzle adapter. Should a discrepancy be found on the combustion chamber, the defective nozzle could easily be identified. Disconnect the fuel delivery line from the flow divider and dump valve. Install blanking caps. Remove the bolts which secure the locking plates and the nozzle adapters to the gas generator case at each nozzle adapter location. Remove the locking plates. Disengage the fuel transfer tubes, which interconnect the nozzle adapters, by pushing the tubes toward the adapter. Remove the nozzle adapters and discard the gaskets. Place the fuel nozzle adapter assemblies in a suitable container, as the fuel nozzles will be checked later. Carefully withdraw the combustion chamber liner from the gas generator case. To remove the shroud segments, we must split the shroud housing assembly at flange E. First, remove the interstage sealing rings. Make sure they are properly marked so they can be reinstalled in the same location. Remove the 14 bolts securing the shroud housing to the small exit duct. Using jacking screws if necessary, split the shroud housing from the small exit duct and withdraw the vane assembly. Remove the shroud locating ring and mark the location of the gap of the shroud retaining ring. To withdraw the shroud segments, remove the shroud retaining ring. Place the shroud housing on the bench with the flange down and remove the segments with a fiber drift. The procedure to select the proper class number will be demonstrated later on. Before reassembling the engine, we will proceed with the inspection of the hot section parts. We will show you the critical area to be inspected. However, for further details on limits, acceptable and non-acceptable, refer to the PT6A-65 maintenance manual. With the combustion chamber outer liner being removed, inspect the diffuser section for cracks, distortion, overheating, corrosion, and evidence of oil leaks. Inspect the combustion chamber inner and outer liner for cracks, buckling, and burning. Cracks in the liner surface are usually of a stress-relieving nature and are usually not serious as rate of growth decreases as cracks lengthen. Typical liner distress consists of buckling and cracking of cooling rings. We will now inspect the compressor turbine vane ring assembly. Inspect the vane ring cooling air inlet and outlet ports for signs of damage and blockage. Inspect each vane trailing edge for signs of multiple hairline cracks. Inspect the inner and the outer ring of the vane assembly for cracks. Finally, inspect the entire assembly for signs of coating loss. The next items we will inspect are the compressor turbine shroud housing and the shroud segments. Inspect the shroud housing for signs of distortion and fretting wear in the interstage sealing ring groove. Also, inspect the condition of the interstage sealing rings. Examine each shroud segment for evidence of metal buildup and cracks. This is the compressor turbine which drives the compressor rotor assembly. Handle the turbine with care since it is a vital part of the engine. The inspection criteria for the compressor turbine are corrosion. None is acceptable on any part of the turbine assembly. Some circumferential movement at the blade tip is acceptable, but no axial movement is permitted. Nicks, dents, and pits. Inspect the airfoil surface and the fillet area for these, and refer to the maintenance manual for limits. Also look for nicks, dents, and pits at the leading and trailing edge of each blade. Finally, inspect the leading edge tip for erosion. Take note that cracks are not acceptable anywhere. Caution. Handle the small exit duct with care. Impact with hard objects may damage the ceramic coating. Inspect the small exit duct for fretting wear at the duct flange that contacts the combustion chamber liner. If wear is in excess of the acceptable limit, ducts should be returned to an approved overhaul facility for possible repair. Before testing the nozzles, remove the sheath from the nozzle adapter. If too much resistance is encountered, use the puller in the following manner. Install the nozzle adapter in the puller. Push the retaining pins in the sheath cooling holes and turn the nut on the puller until the sheath splits from the nozzle adapter. Caution. To eliminate danger of electrostatic discharge, before doing the flow check, connect the ground cable to a suitable ground point. Insert one blanking tube into the nozzle adapter and connect the adapter to the test rig. Install the lock plate and secure with screws and nuts. Gradually, adjust the pressure to 20 psi. A conical spray, free from spitting or drooling, should appear. Increase the pressure to 60 psi. The volume of spray should increase and be evenly spread about the axis of the nozzle orifice. If more than 20% streakiness is evident, reject the nozzle. Streakiness is defined as a variation in spray quantity between different parts of the spray cone and appears as darker streaks in the spray, as we are showing you now. Streakiness may be caused by external carbon deposits around the nozzle orifice. Remove the deposits by lightly brushing the nozzle face with a bronze or non-metallic bristle brush while fuel is flowing through the orifice. If a nozzle is replaced, a leak check should be done. To leak check a nozzle, install the nozzle adapter in the leak test fixture. Turn the knob on the fixture until the nylon pad contacts the nozzle orifice. Connect a supply of clean, compressed air or nitrogen and apply a pressure of 500 psi. Check for leakage using leak check fluid. Leakage is not permitted. After all the nozzles have been checked, store them in a proper container before installing them on the engine. Now that we have inspected all the parts, we will reassemble the engine. If new parts are installed or a gas leakage is suspected, the following mating surfaces must be lapped. Lap this face of the small exit duct until 100% contact is achieved using the recommended lapping compound. Lap this face of the vane ring until 100% contact is achieved. Then lap together the two previously lapped faces of the vane ring and the small exit duct. Remember that the lapping procedure is very important since it provides sealing for the gas path. Also, lap the inner face of the vane ring until 100% lapped surface is achieved. Finally, secure the lock plate and the number 2 bearing cover flange to a suitable backup plate. And lap this face of the lock plate until 100% lapped surface is achieved. The symptom of poor sealing is higher running temperature than normal at a given power. When new shroud segments are installed, proceed as follows. To select the proper class number for the shroud segments, first measure the outside diameter of the bladed disc at several places and record the largest diameter. With that dimension, find the recommended class number in the maintenance manual. Before installing the first segment, suitably support the shroud housing so that there is a sufficient gap between the shroud housing and the workbench. Install the first segment in the retaining grooves, positioning the end of the segment at 250 thou minimum from the nearest cooling hole. Then install the remaining 9 segments using suitable shim stock between them to facilitate gap equalization. Remove the shim stock when the segments are firmly located in the shroud housing groove. Secure the shroud segments with the shroud retaining ring, aligning the retaining ring at the previously marked location. Install the shroud locating ring. With the housing assembly on the bench, with the slotted flange uppermost, install the vane ring in the shroud housing. Load the vane lugs to one side in a clockwise direction. With a feeler gauge, measure the clearance on the loaded and the unloaded side. If necessary, reposition the vane ring to achieve clearance. Clearance at all 14 lugs should be within limits. If necessary, stone the offending lugs to achieve clearance. If clearance or side play is found to be excessive, it must be corrected by rework at an overhaul facility. When you are satisfied with the fit, place the shroud housing over the small exit duct. Align the holes and secure with 16 bolts, torque to specification, and safety wire. Install the interstage sealing rings and ensure that the index marks are aligned. We are now ready to put the hot section back into the engine. To facilitate the reassembly of the hot section, install 2 threaded dowels in the number 2 bearing flange. Install the combustion chamber outer liner in the gas generator case, ensuring the correct position of the offset hole. Install the 2 igniter plugs to temporarily support the combustion chamber in its proper position. Locate the number 2 bearing cover flange in the combustion chamber outer liner. Align the offset hole. Install the assembled vane ring and shroud housing assembly in the gas generator case. Without using force, engage the vane ring inner lugs with the corresponding slots on the number 2 bearing cover flange. If resistance is encountered, re-index the assembly in each of 8 positions until the best location is determined. If a free hand fit cannot be found, locate and stone the offending lugs on the vane ring. Locate the lock plate into the center bore of the vane ring and ensure that the chamfered face is located at the interface. Secure the lock plate, the vane ring, and the shroud housing to the number 2 bearing flange with 16 bolts and tighten to specification. Check that the complete assembly has no rotational movement. A slight axial movement may be evident. Lock the tab washers. Install the number 2 bearing cover over the protruding center bore of the number 2 bearing cover flange. Light tapping with a soft-faced mallet is permissible. Locate the compressor turbine stator air seal on the number 2 bearing cover. Secure the baffle with 8 bolts. Torque and lock as per the maintenance manual. We have assumed that the shroud segments had to be replaced. Replacement of the compressor turbine shroud segments may entail localized grinding in order to obtain the required turbine blade tip clearance. To determine the amount of metal which must be removed, proceed as follows. Install the grinder adapter on the compressor front stub shaft. Install 4 rubber spacers under the small exit duct, set approximately 90 degrees apart. Apply even pressure on all 4. Zero the dial indicator on the gauge master. Install the indicator on the adapter with the indicator plunger on the inside diameter of the shroud segments. Rotate the gauge and record the inside diameter of the shroud segments. Calculate grinding requirements as shown in the following typical example. From the diameter of the shroud segments, which is 9.184, subtract the diameter of the compressor turbine. We measured 9.170. The difference divided by 2 gives us an actual radial clearance of 0.007. If the required clearance is 0.012 and the actual clearance is 0.007, we have to remove 0.005 of an inch from the segments. With this information, let's proceed with the grinding operation. Before grinding, use adequate material and blank off all the cavities around the combustion chamber outer liner and the vane ring. Ensure that the grinding wheel is freshly dressed or new. Install the grinder on the adapter and make sure that it turns freely. Position the grinding wheel at the inner edge of the shroud segments by adjusting the axial vernier. Connect the air supply line to the shroud grinder. Rotate the shroud grinder and adjust the side vernier until the grinding wheel contacts the high spot on the segments. After a few complete turns of the shroud grinder around the segments, maintain rotation while adjusting the axial vernier 2 complete clockwise turns. Repeat the clockwise adjustment of the axial vernier after every few turns of the grinder until the grinding wheel reaches the outer edge of the segments. Do not attempt to grind too much material from the segments during a single pass. Repeat the grinding operation until you obtain the required compressor blade tip clearance. After grinding is completed, remove the grinder and vacuum any abrasive dust. The next step is to reinstall the compressor turbine assembly. To install the turbine, apply a light film of Molykote G to the splines on the turbine stub shaft. Align the master spline and install the compressor turbine in the compressor front stub shaft. Ensure that the new key washer is free from burrs and other surface damage. Apply a light film of Molykote G to the inside of the washer. Also, apply a light coat of Molykote G to the shoulder and threaded section of the center bolt. Install the key washer and bolt into the center bore of the installed compressor turbine assembly. Make sure that the lugs on the key washer are engaged in the compressor turbine slots. Using a conventional torque wrench, tighten initially to the recommended torque, then slacken off to 0. And finally, retighten to specified limits. This double torquing is necessary to seat the compressor turbine properly. Remove the protector sleeve. With a set of feeler gauges, measure the tip clearance once more. If the tip clearance is within limits, install the key washer squeezer in the center bore of the turbine. Lock the key washer with the squeezer. Remove the squeezer and inspect to make sure that the turbine bolt is properly locked. Install the combustion chamber inner liner in the combustion chamber outer liner, ensuring that the flange of the small exit duct engages with the sealing ring on the rear of the inner liner. Align the bolting flanges on the inner and outer liner. Secure the flanges together with 14 bolts and torque to specification. The combustion chamber is also supported by the fuel nozzle adapters. Install the previously checked nozzles on the engine, making sure that you install them in the right pattern. This is extremely important for good starting characteristics. After all the nozzle assemblies have been installed, torque to specification and lock wire. Prior to mating the power section to the gas generator, check the T5 system in the following manner. Connect the test set to the alumel and chromel terminals and measure the loop resistance of the T5 system. Resistance should be within limits. Connect one lead of the test set to either the chromel or alumel terminal and the other lead to ground. The measured insulation resistance must not be less than the specified limit. It is also advisable to make a heat response check. To do so, connect the test set to the chromel and alumel terminals. Heat each probe with a suitable heat source. Make sure the thermocouple is reacting to heat by observing movement of the needle on the test set. Also, be sure that the needle always deflects in the same direction. If the needle should go in the opposite direction, it would indicate that the thermocouple is defective. After attaching the lifting sling to the power section of the engine, check that the interstage sealing rings are well seated in the groove on the shroud housing. Apply a light coat of sealant at C-flange. And mate the power section to the gas generator case. Secure with nuts and bolts and torque to specification. This completes the hot section inspection. Have a safe flight.